So it's probably pretty safe to say that you struggle or probably just flat out hate word problems. And I don't blame you. When it comes to word problems, you really only have about 2 minutes on the ASVAB per question. And in that time, you have to understand all of the information that's given to you, what the question is asking you to do. You have to go ahead and make a plan or understand what formula is supposed to be used. Then on top of that, you have to go ahead and use the formula the right way. And on top of that, you have to avoid blanking out and getting nervous and anxious about decimals, fractions, or any weird numbers or situations. And so, with that said, I'm Coach Anderson, and in this video, I'm going to show you what the 3 steps to word problem success are. That way, you can go ahead and tackle word problems the right way every single time. And the great thing about this strategy, not only does it help you keep calm, cool, and collected, and avoid test anxiety, it also helps you understand exactly what you did right and what you did wrong so you can build your confidence one problem at a time. And so, before we get started here, I have one quick favor to ask of you. Please go ahead and smash that like button, because at the end of the day, by smashing that like button and then later on at the end, commenting what you enjoyed about the video helps this video reach everyone else who needs it, just like you. And so, let's go ahead and work together, my ASVAB party people. Let's go ahead and get started, and let's learn how to crush word problems just like this. Let's go. All right, so let's dive right on in, my ASVAB party people. The 3 steps to word problem success. I promise you, again, if you follow these 3 steps to every single word problem, no matter what word problem it is, if you follow these 3 steps, you're putting yourself in a position to succeed every single time. So let's learn how to lower that test anxiety by following these 3 steps. And again, this happens before you calculate anything. This helps you avoid the distraction of weird numbers or situations by first understanding the question. The first thing you should always do in every single word problem, my party people, is understand what the goal is. So let's think about it real quick. If you were, let's say, not even doing math, let's say you were playing a game with a friend or a sibling or a family member, and that family member or friend didn't tell you what the rules of the game were, they didn't tell you how to win, they just said, hey, Anderson, or hey, person, let's just go ahead and play this game, and we're starting right now. Let's go, good luck. And then you see everybody doing something and something and something, and you're sitting there like, what do I do? Right? That's not a fun game. That's not a fun game at all. I think we can both agree that that is not a fun way to go about it. If you want to play a game and have fun, the first thing we all ask is, well, how do you play? What do you need to do to win, right? We always ask that. And so that's the first thing that you should do when it comes to word problems. That anxiety comes from not knowing what to do, not knowing what we're supposed to be figuring out. And if the first thing you do is snap your attention to the question, so that last sentence where it asks you, who, what, when, where, why, how many, which of the following, when you go straight to that question, you're going to allow yourself to understand what the goal of the problem is. Now, is that gonna automatically say, hey, this is the exact math you need to do? No. Sometimes it does give you the math with some keywords for sure, and sometimes you need to go ahead and read into the story just a little more. But the fact of the matter is, when you start with the question, you now understand what the goal of the problem is. And once you understand the goal, then this is where we go from, hey, what do we want? So read the question, to what do we have? What do we have? And this is where we start writing down the information that's given to us so we can figure out, okay, how is this related to the question? How is this related to what we want? Because when you write down the information already knowing what you want, if you understand some of those formulas, if you understand some experience with some of those questions, you'll start understanding that, oh, that's this, that's a rate, oh, that's distance, that's this. And you'll be able to calmly, coolly, and collectively move forward. So here's my big tip here when you're writing down the information you have. Make sure to not just write down the numbers, but always write down what they mean. Because this is a big lesson here. It is not about what the numbers are, it's about what they mean. So for example, if you're doing a word problem and you just write down the number 7, 7 what? 7 watermelons, 7 miles per hour, 7 years. What does that number mean? Because remember, we can create a million different word problems with different numbers with the same words. It's about what the numbers mean, not about what the numbers are. We can switch the numbers up all day, every day. I've created so many tests. We can do that all day. So let's go ahead and get right back to it here. First step, what do you want? Read that question. Step 2, what do you have? What information do you have that is related to that question that could potentially help you? And make sure to write down the information in terms of what the numbers mean. Write down the units. And step 3, this is where we start building a connection. What's the connection between what we want and what we have? What is the connection? And that's where you really start getting the experience of, oh, I know that if I have a rate and a time and I'm looking for distance, oh, that's a distance, rate, time problem. Or if you notice that, hey, we just compared light bulbs per hour and then this many light bulbs in that many hours. Oh, that's a proportion problem because you're comparing the same things in the same way. And so as you keep learning these topics and as you keep practicing word problems, you'll get that experience in identifying what topic you're doing every single time. And that's the great thing about it. And that's why you need to go through these 3 steps before you calculate anything. If you try to calculate without having a plan, you tell me if this sounds familiar. You tell me if you've experienced a situation where you start a problem out, you don't really know exactly how to do it, but you start taking some numbers, smashing them together, adding them, multiplying them, and then maybe you see an answer choice that has one of those calculations in there. And you're like, wow, I don't know how I got there, but there's that number. Let me pick that number, let me pick that answer choice, and then turns out you got it wrong. Because I can guarantee you, a lot of the questions that you'll see will have distractor answers. They will have answers that will make you believe that it's correct because it appears somewhere in that calculation process. And that's why it's so important to know what you need to do and why you're doing it before you actually calculate, because it avoids those distractions. It avoids being tricked into picking the wrong answer. And so, my math party people, my ASVAB party people, you know that this isn't enough. You know that we need to go ahead and put this into practice and see exactly how the 3 steps to word problem success fits in to really all the types of word problems that we can see. So in this video up next right now, I'm going to show you 3 problems that you can try out with me using the 3-step strategy. Start off with the question, what do you want? What do you have? What's the connection? Let's go ahead and dive on into example problem number 1. Let's go. So let's go ahead and get started here. Ming spent Stop right there. That's the complete wrong way to start word problems. The way that you want to start word problems is by first, what's the question? What do I want? Because think about it. We're not going to put ourselves out in the open when we don't know what's going on. And that's what you're doing here. You're just going ahead and going along for the ride. Start first by reading the question right here. How many candy bars did she buy? Remember, look for those question action words. Who, what, when, where, why, how many, which of the following. Those are those action words that you're looking for. So how was right there. So we're looking for how many, so the amount of candy bars that she purchased, which is Ming in this case. Okay, that's the first step. What do I want? I think we can all understand the question, right? Yeah, we want the number of candy bars. How many candy bars? So number of candy bars, that's what we'll start off with every single time. And I'll just use C for candy bars because I don't know what it is. Just put in C, A, X, doesn't really matter. But that's the first step. Step number 2, after you know what you want, now it's time to understand the information you have. The 3 steps to word problem success really comes down to, hey, can I understand the question? Can I understand how the keywords in the problem relate to a formula or an equation or process or procedure? And then calculate quickly and confidently. But you can't get to calculating if you don't have a solid plan. So I say this all the time. Let's go ahead and get to it here. What is our plan going to be? Well, since we're looking for the number of candy bars, I'm going to look for all of the information that's related to candy bars. That's all I care about. So it says Ming spent this much money on a magazine. Don't worry about the numbers until you know what they mean. So this much money on a magazine, some candy bars. Okay, so she purchased some candy bars and a magazine that totaled $19.40. Okay, I can go ahead and write that down. So again, this is what I want. Here's what I have. We have $19.40 spent on a magazine. So be very, very careful though. A magazine, one magazine, not 2, not 3, not 4, just one. So on a magazine, so one one magazine, and some candy bars. Do they specify how many? No, and that's exactly what we're looking for. Remember, we're looking for how many candy bars. We don't know what that is. We're looking for it. So on one magazine, and we're just going to say C candy bars. C candy bars, right? And so with that said, okay, what other information do we have? Well, we know that the magazine costs $2.60. Okay, so I can say that again, one magazine right here. I'm going to use blue, $2.60. That is $2.60. And then it says, ooh, there's a key word here. Each candy bar. Each candy bar is $4.20. So remember, the word each, or for every, or per, that always indicates either multiplication or division, depending on which direction you're going. To be safe, typically you're doing multiplication, but the way that you know is, hey, if I am going toward the result, then you're multiplying. If you're going toward the piece, you're dividing. So if that doesn't make too much sense, no worries. Just think multiplication for right now, and then we'll expand on this in later videos. But think of it like this. If you have C candy bars, and they're each $4.20, so C candy bars, $4.20 each, you would be multiplying to get that total amount spent. Think about it. If it was just a regular, easier number, like $2 a candy bar, if you had one candy bar, that's 2 times 1, $2. If you had 2 candy bars at $2 a piece, $4. 3 candy bars at $2 a piece, $6, because you're multiplying to go forward to that total price. So again, you have to make sure you understand what these keywords mean, because the plan is the most important part. Every single time, full stop, every single time. So what this all means is this. We're going to translate this. We're going to say that the $19.40 that was spent right here, the total amount spent from Ming, is equal to the magazine and the candy bars together. Is that fair to say? The total amount that we spent was spent on the magazine and the candy bars together. So we can create an equation out of this. And this equation is going to be this. Hey, 1940 is equal to the cost of the magazine, so the $2.60, and, which is the same thing as saying plus, C candy bars, $4.20 each. That will take us to 4.20 times C. Now, this is just one way to go ahead and approach the problem. This is just one way. Another way to approach this would be, well, look, if you want to know how many candy bars you purchased, well, then you need to know how much you spent on just the candy bars. So what you would do is you would take out the magazine, that $2.60, you would take that away from the $19.40, because what you have left would be the amount only for the candy bars, and then you can do your job and divide and get the answer. That's one way to do it. I'm going to do it in the form of setting up an equation, because this is a skill that is absolutely necessary. Not every problem is going to be pretty enough to solve like that, where I said just subtract and divide. Not every problem is like that. You got to be ready to solve the more complicated problems, and so that's why I really do encourage you to learn how to write equations, because all equations are just math sentences. That's all they are, representing the situation that you're looking at. So with that said, let's go ahead and get to it here. So the way that we're going to solve this is by doing this. Well, let's get rid of that $2.60. We're trying to get to C. We're trying to get the number of candy bars. So we got to get rid of this first, and then we'll get rid of that 4.2. So what do? Subtract on both sides. Now remember, that's exactly what I said we would do, even without an equation, right? Even without an equation, we would get rid of the magazine. That way we only have the money spent on the candy bars. I gotcha. And so with that said, booyah, that's going to cancel out right here. And so what we'll have here, 19.4 minus 2.6. You can use your mental math here. I encourage it, because with mental math, what you would see is that, hey, I can take away 2 first, 17.40, then take away 60 cents. So you can take away 40 cents, then 20 cents. So that would be 17.40, $17 taking away 40 cents, then 16.80 taking away the extra 20 cents. So you can get it like that. Or again, you can go ahead and do it by hand as you're used to. No harm, no foul. But there we have the 1680, and that's going to equal, we still have that $4.20 right there. 4.20 times C. So what's going to happen now? Well, remember, what's happening right now is that these are being multiplied. And so 4.20 times C is equal to 19.40, or excuse me, 16.80. My bad, wasn't looking. And so what you're going to do now is divide both sides by 4.20. Nice and easy. So by dividing both sides by that, we'll give ourselves the opportunity to get the answer. Right there, right there. And you may be looking at this saying, okay, how do I do this? Decimals, ew, I don't like this. It's all good. All you have to do, you can use this little trick that is very common. You can move the decimal over here and there. Remember, whatever you do to the top, you do to the bottom, right? Fractions. So you can do that to turn this into 168 over 42. And then from here, you can go ahead and divide. Now, by doing this, you can't do long division because 42 doesn't go into 1 or 16. So you're out of luck there. But one thing you can do is you can notice that, well, both of these numbers are even. I can start off by dividing them both by 2. If you're trying to do this mentally, they're both divisible by 2. And so if you do that, that's going to be 84 divided by 21. And then if you divide, oh, I know that 21 can go into 84. I know that for sure. That's actually 4 times. And so if you're having trouble seeing that, let's see right there. We have 4 candy bars. So if you're having trouble seeing that, then I really do encourage you to work on your mental math. This is way too important, because if you're not sure how to calculate with your basic arithmetic, then it's going to make it a lot harder to plan word problems out, because it takes you longer to calculate, you have less time to plan. So you do want to make sure that you work on your mental math. That's the best advice I can give anybody. But at the end of the day, my party people, let's go ahead and do the little things right, and so that way the big thing takes care of itself. And so, how'd that go for you? What do you want? What do you have? What's the connection? I want to drill that into your head, because it's exactly how we're going to get things done here. So let's go ahead and dive on into the next example. Example number 2. Not going to tell you the topic. We're just going to go ahead and practice that strategy one more time. Let's go ahead and keep raising our scores here. Problem number 2. So first things first, when we're doing a word problem, first things first, what do we always do? Read the question. And so if you're in my classes already, you have probably said that along with me when I said read the question. I got you. But if you're not in my classes, you're going to learn. I got you. So first things first, read the question. The whole if she wants to, that's not the question. The question is, how much must she make in total sales? That's the question right there. So right over here, how much must she make in total sales? So essentially what we're asking is the dollar amount for total sales. Cool. Sounds good. I don't know what that means yet, but I know that's what we're looking for. We are looking for blank in total sales. Now, yes, you may be looking at the word total and you may be thinking, well, we're going to add something up, right? Be careful. Total just means the entire amount. And a lot of the times, yes, it does mean add it up to get there. But other times, well, it really depends on the topic. It depends on what we have to work with. So we're looking for total, or the entire amount. Okay? So that's what we want. Step number 1 in every word problem is, what is it that we want? Now let's take a look at the information that we have. What do we have to work with? Because if we know what the goal of the problem is, or what house we're trying to build, well, then let's take a look at the information. Like, what's the location? What's the foundation like? Is there a lien on the property? All this good stuff, right? So let's go ahead and check this out. Step 2, let's gather the information. Let's let the problem develop. Here we go. Geraldine works as a sales agent. Okay, sounds good. Thanks for the context. She earns a 4% commission on each sale she makes. Okay, that's important. Let's go and highlight that. Earns 4% commission on each sale. Sounds good. So Geraldine earns 4%. Earns 4% on every sale. So if there's a sale, you multiply that by 4%, and that's going to be her commission. That's the thing right there. That's one of the hints of the problem. That's one of them. So we make a sale, multiply that by 4%, and we'll get the commission. Okay. Now look at this. How much must she make in total sales? So whatever that number is that we have, that's what we're multiplying by 4% to get Geraldine's commission. I'm going to write that down in a moment, so don't worry, but I got you. It says if she wants to make a $450 commission, let's go ahead and highlight that. So we want a $450 commission. So the commission was, or will be, $450. Okay, so you may be looking at this and you're thinking, well, we multiply the 450 by 4%, right? No. This is why it's so important to understand how percents work and how to notice whether you're going forward or backwards. Because remember, the 4%, you earn 4% on the sale, not 4% on the commission. That doesn't make sense. Your commission is the result. The commission is what you get after the sale's done. So with that said, we're looking for what we need in total sales. So this is where things happen now. So I'm going to go and zoom on over here. I'm going to zoom on in, and here's what we're going to do. What we're going to do is this. Let's write this in English first and then translate it into math. So what we're saying is, so the percent of the sale equals the commission. Yes or no? Is that true or false? Just speaking in plain old English here. The percent of the sale gives you the commission check. So let's say, you get whatever percent on buying or selling this $1 million home. Cool. You take the percent of the commission on that $1 million home, and let's say that percent turns out to be like $20,000. Cool. Then that $20,000 is mine. That's my commission. So notice what I just did there. I took the percent of the sale, and that gives me the commission right there. The percent, so 4% of the sale, which is what we're looking for, So the 4% of the total sales equals the commission, the $450 commission right here, right there. So I'm going to circle that nice and easy, the $450. Booyah. So now that we're looking at that, now that we can see it with my big old head out of the way now, check this out. This is pretty neat. Because we know exactly what the setup looks like. We just turn this into math and solve, and we are good. How do I know how to do this? Just like this. What do we do with a percent? Before we multiply, we turn it into a decimal. And what do we do? How do we do that? We take that decimal place, move it over 1 twice. So it's going to be 0.04. Remember, a percent is out of 100. So if you divide by 100, which is the same thing as moving that decimal place left 2 times, we will get 0.04 of, meaning multiply, right? The total sales, which is again what we're looking for. So we'll just write T for that. That's going to equal the commission that we want, which is $450. So now that we've set this up, we know we've set this up properly. Now all we have to do is figure out what T is. And this is what I mean when I say that we're working backwards, because we're going to be dividing both sides by 0.04. Right there, right there. And once we do that, guess what? On the left side, cancels out, leaving us with the T that we want. So we'll have T equals whatever that is. Now, if we want to go ahead and perform this division, and you're looking at this with decimals like, I don't like this at all. Hey, you're not alone. A lot of people say the same thing. But what you can do to actually make your life easier when dividing by decimals, remember this with fractions. Whatever you do to the top, you must do to the bottom, right? Whatever you do to the top, you must do to the bottom. And so what that means for me, at least, is, hey, if I wanted to just get rid of this decimal and move it to the right 2 times, I would take this decimal right there, move it to the right 2 times. Make my life easier. I'd make my life easier, just like that. So that turns into, let me just move this over here. That turns into 450 with 2 extra zeros divided by 4. That's what that turns into. That's actually nice and easy, right? That is nice and easy. Let's take care of business and let's have a good time. So here, we'll divide 4 into 45,000. So 4 goes into 4 one time. Subtract that 4. Then bring the 5 down. 4 goes into 5. Again, 1 time. Subtract the 4. You have a 1 left. Brings down the 0. 4 goes into 10 2 times because that's going to be 8. Let me get my big old head out the way. That's a 2. Bring that other 0 down. That's going to be 20. 4 goes into 25 times. That's going to be a clean. That's going to be clean right there. And then we still have that other 0 coming down. 4 goes into 0, 0 times. So it looks like to get that commission check of $450, it looks like Geraldine's going to have to sell $11,250 worth of a home, which is actually, or is that, we're talking about homes here, or we're talking about just regular sales? Sales agent, okay, cool. Because I made the analogy of a home. But it just looks like we just need to sell $11,250 worth of whatever to get that commission check of $450. And that's it right there, my party people. And that was problem number 2. So notice, it was a percent problem. We could probably understand that from the very beginning, but maybe we didn't know that we had to work backwards. And that's why understanding what you want, then what you have, then the connection, before you calculate, that's what gives you the opportunity to do it the right way and to learn from any mistakes to see, hey, what did I do right, but what can I do better? So let's go ahead and get ready for this next example. Example number 3, it's the last one. And remember, if you haven't done so already, please, please, please go ahead, like that video, smash that like button, and comment your favorite part of the video. Again, we're trying to spread the word to as many people as we can, just like you, who want to succeed. So let's go ahead and work together to get that done. Let's get it done. Hey, my math party people, let's get to it. So we have all this word, all this wording here. And as I always say, you want to make sure to just start with the question to make things easy for yourself. Because we're still going to read the whole problem. We're still going to read it, but you might as well read it when you know what it is that you're trying to find. Because it makes the information a little more interesting as opposed to reading it nervously, not really knowing what's going on, not really knowing what you need, right? So that's why I always say start with the question. So let's get to it here. We want to know what we want, and what we want is always in the question statement. So again, we're asking right here, how long did it take Jessica to get back home? And how long? Well, we look at the answer choices, and these are all in hours. And so what we want is blank hours, so blank hours to get back home. Okay, so that's what we want, blank hours to get back home. Now let's go ahead and understand Jessica's situation. Let's understand her situation by collecting the information to ask, what is it that we have? Let's get to it. So in purple here, I'll go ahead and highlight what I have here. When Jessica drove to see her parents at 75 miles per hour, it took her 4 hours to get there. Okay, so remember, drove to her parents, okay? Drove to her parents. That's pretty important information. Let's go ahead and write that down here. So what do we have? We have to her parents. We have 75 miles per hour. What is that? 75 miles per hour. That's a rate. Per hour. Miles per hour. That's a rate. That is a rate. And then we see 4 hours to get there. That is a time. So I'm looking at this and I'm saying, hey, I have a rate and I have a time. Distance equals rate times time. Ooh, I'm starting to see that connection forming already, right? But let's make sure to not get ahead of ourselves. Let's collect the information so we know what's going on here. And so in the next sentence it says, on the way back, she drove at a speed of 80 miles per hour. Okay, so on the way back, let me just highlight here. On the way back, drove at a speed of 80 miles per hour. And so to her parents and then back home. Back home, we have 80 miles per hour, and that itself is also a rate. And so let's ask ourselves, what is the connection here? What is the connection? All right, so the connection that we have, let me just write out connection here. The connection that we have, truthfully here, is that we're dealing with a distance, rate, time problem. We're dealing with a rate problem. Distance equals rate times time. Distance equals rate times time. Another way that we know this is D equals RT. D equals RT. That's another way we know it. That's another way we know it. And so let me rewrite that because that just bothers me how ugly I wrote it. D equals R times T. Distance equals rate times time. You got to write that down. You got to know it. You got to know it. You got to have it ready to go whenever you need it. So let's ask ourselves, Okay, if we're looking at back home, then we only care about this in terms of back home. What's the problem with that? Well, the problem with that is we only have the rate given to us, but we're looking for, again, hours. So we're looking for time. This is time right here. And so we're looking for time. And so if we plug these things in, I'm just going to put T for time. And I'm going to write the rate, the 80 miles per hour that I have. Because again, I'm only talking in terms of getting back home. My question now is, what the heck is the distance? What's the distance? It wasn't given to us. It doesn't tell us how far she drove back home, right? And so this is where we have to get a little savvy. Because what did you notice about the situation? Jessica drove to see her parents, and then she drove back home. Is there anything that we can reasonably assume about this problem? What we can reasonably assume is that she took the same distance. It takes the same distance to get to her parents' house and back. It's pretty similar to saying, hey, I walked down the street to my friend's house and then came back home. I think we can assume that we took the same route. Down the street, then back, same distance. And yeah, we can healthily assume that here. We can healthily assume that. And so we can take a look at this part right here. To see her parents, we have the rate, we have the time. Remember, D equals RT. Distance equals 75 miles per hour. Because again, this is to her parents, okay? This is for the situation for to her parents' house. So R is 75, T is 4. What is 75 times 4? Remember, multiplying by 4 is the same thing as multiplying by 2 twice. So 75 times 2 is 150. 150 times 2 is 300. And so my distance here is 300 miles. And we can absolutely say that because Jessica goes to her parents and then back, the distance here is the same as the distance there. They are the same. And so I can plug in 300 right here. Boom. So we have 300 equals 80 times T. And so with 300 being equal to 80T, all I have to do now is divide both sides by 80, and I'm good. And so over here, what's going to cancel out? The 80 and the 80, because you're dividing by itself, right? And so then we have T equals whatever 300 divided by 80 is. So initially, I can just look at this and say, hey, look, the zeros cancel out. So you have 30 divided by 8. And so if you want to go ahead and do that, in your head, sure, do your thing. If you want to go ahead and do long division, again, do your thing. You'll get the right answer either way. The answer to this question is going to be D, 3.75 hours after you do the math. Because again, T is hours here. And there you have it. And so if you wanted to do the long division, you can absolutely do the long division. Allow me to erase this over here. Please go ahead and rewind if you'd like to see all of this done again. Let me just erase all of that. All right. And so I can show you the 8 going into 30. 8 goes into 3 0 times, but 8 goes into 30 3 times. So we'll subtract the 24 because 3 times 8 is 24. We have 6 left over. Put a decimal place to keep going. Drop the 0. 8 goes into 60 7 times because 7 times 8 is 56. So you have a 4 left over. Bring another 0 down. And then 8 goes into 40 5 times. 3.75 hours. That's our answer. And there it is. And that concludes our video, ASVAB Party people. 3 steps to word problem success. How to do word problems the right way. Always start with the question. Then once you know what you're looking for, then it's about figuring out how to get there. And that's why we need to start with the information. And as a reminder, always write down what the numbers mean. It's not about what the numbers are. It's about what they mean. And then on top of that, once you have your information, then that's where you go ahead and take a look at what you're looking for, what you have, and build that connection. You can tell where your biggest problems are by first going through each step. Because if you're stuck on the connection, then maybe you don't know the concept very well or the key words you need to understand. And so we need to, it's a must in terms of following this 3-step strategy so you can succeed at the end of the day, my ASVAB party people. Again, I'm Coach Anderson, and please go ahead and smash that like button if you enjoyed this video, subscribe to the channel, and comment your favorite part. That way this video can reach everyone else who needs help with the ASVAB. I'll see you guys in the next video. Let's ace the ASVAB. And so we both know this video just helped you with your test anxiety by just a little bit. And to keep lowering your test anxiety and keep raising your confidence, that's what my ASVAB All Access program is for. The link's right up here. Click it, watch the video on how it works, and you'll see exactly why thousands of my students have raised their scores and gotten the jobs they want. So click there, watch the video, and sign up to raise your score. I'll see you soon.